Hello, everybody. Let me get that out of the way. There we go. I wanted to give you the presentation about windmills and just some little information about, for distance learners, people who aren't in class right now, you're quarantined, whatever the reason. That way you have some information and what to do, virtually speaking. So let me put this slideshow on about windmill construction. There's some videos and some of the bell works and other assignments previously, so make sure you go back and have viewed those if you haven't already. What's a windmill? Basically, what a windmill does is it'll harness the power of the wind and it turns it into rotational energy. Usually when you see a windmill, you see the fans, the fins, and then it's spinning like this, sort of. It's got a rotating axis. It's horizontal. The wind pushes the sails, they turn the axle, and that turns the wind into mechanical energy. So that's the first thing to talk about. What do people use this for? There's a lot of things in the past people have used this for. And one of the biggest things is grinding grain into flour. The word mill actually comes from the act of grinding grain into flour. So when you hear about a windmill, that's the very first thing they try to do with it is grind grains. Here's a picture of it happening. These giant stones roll around and they squash the grains, and there's usually some sort of a scoop that comes around and follows in a circle and scoops the grains back into the path of the stones, so it just keeps rolling over them over and over again. It can move water to higher ground, like drain low-lying parts of the land for farming. That's something that the video about the Dutch windmills talks about. The polders, what they would do is all this low-lying land, they would build up a dike to block some of it off, and so there'd be basically a pond now. And then the windmills, or a series of windmills, would be employed to scoop the water up out of the low-lying land and move it to higher ground, and eventually out to the ocean. And that's how they made so much of the farmland that they have in Holland. Here's one example. There was this paddle wheel design, and it would just take scoops of water, take scoops of water, take scoops of water up. And then once the Archimedes screw was invented, that's this thing it's like an auger. If you've ever used an auger to dig up dirt, if you've ever used a drill to go into ice fishing, which we're in Mississippi, most of you probably haven't. It's just something I know uses the same principle. It's just it's a screw with these giant threads around it. And in the case of an Archimedes screw, these threads make contact with the entire bottom part of a trough. And as the screw turns, that thread moves the water up and out of the trough. So there's a picture of it down here as it moves things up. And you kind of could see it when you saw the video, I hope, from the gentleman who lived in the windmill, which is really neat. And one thing they use it for a lot is sawing and processing wood. In the video, they also mentioned pressing art, making paper, things like that, but I couldn't find a lot of examples of that. So the main three that I want to focus on is just grinding grains, moving water, and sawing wood, processing wood. And there's a whole video, I don't know if I've linked it before, about, and if I haven't, I can link it in the activity that I'm writing up right now. But there's a whole video of them using it as a sawmill. Using windmills as sawmills. So the problem with sawing is that you're going to be having to saw vertically, and that's a reciprocating motion. You can't usually use a rotary motion. You got to change your rotary motion into a reciprocating motion. There's a picture, a still from a video, actually, I think, of the saws going, and they go up and down, and people process wood like that. They make planks. You can turn the planks sideways and make posts by sending it through a second time. So how is the motion changed? First of all, the motion caused by the wind is rotating about an axis usually parallel to the ground, high up in the air. So it's going around and around and around in an axis parallel to the ground. Let me find something. A pencil will do. Even better. I've got a Vex shaft. I also call them axles because I think there's an official difference. But so this is attached to the fan, the blades of the fanned out blades on it, and that'll turn the axle. I don't know if you can see it, but it's rotating around in a circular motion. And it's usually high up, way high up. There was a bell work you may have already seen about vertical ones where they have big old sails and they tunnel the wind around them and it turns it already like this vertically. But most of the time when we talk about windmills, you think about the ones that have, like Dutch windmills, they have the fan blades going around kind of thing. So first of all, you've got this way up high in the air to catch a lot of wind, you've got to move it down to a level where humans can actually interact with it. People aren't going to go up 3 flights of stairs to the top of a windmill just to grind their grain. They're going to want it to be somewhere they can easily get in and out of. Next, you're going to have to maybe change the axis of rotation. So not necessarily have it still rotating like this around a horizontal axis, you might have to rotate around a vertical axis. So that's something that sometimes has to change. And of course, like I mentioned with the sawmills, you may have to change it to reciprocal instead of rotary motion. So what mechanisms are we thinking about for changing the location of the motion? Some people have thought about using like sprockets and chains, because if I have a sprocket here and a sprocket down at ground level, put a chain around it, that'll make the motion, it'll keep it in the same orientation, be horizontal, it'll keep it going the same direction, it'll just drop it down low where people can use it. I'm gesturing a lot, and I can't see a view of myself, so I'm not sure how much of my gestures are in frame. I apologize if they're not. I'll try to review it later and re-record if I need to. So yes, chain and sprockets will move it down. Another thing that might do it is a belt drive. You could also have a series of gears, like gears and idlers, just a whole bunch of gears. The safest thing is probably, well, I don't know, it depends. The one that you saw in the video, the Dutch guy who lives in the windmill, actually there's a mechanism in the top of it that changes to a vertical axis rotation, and that brings it all the way down to the bottom, and then at the bottom of it where it's rotating, he can turn it sideways again if he needs to, or he can just, in that case, I think it just has stones attached to it and it's driving around in circles. Oh no, he's not the one with the stones and circles. He's the one that has sort of an angle for the Archimedes screw. Never mind. Yeah, but once it gets to the bottom, he changes direction again with it. Yeah. So there's a bunch of options, and I've had some folks already start on 2 of those options. I can bring over the models. I'll pause it when I'm done with the lecture and bring them over, and you can see sort of what to look at. So changing location. Yeah, you might want belt and pulleys. You might want chain and sprockets. You might want to just change the direction once so you can have an axis that moves it downwards and then change again at the bottom if you need to. How do you change the angle of the axis of rotation? You can use the worm and wheel thing, because the worm goes around this way, but it turns a wheel perpendicular like that. You can also use 2 bevel gears. Bevels are going to come together so their axes are kind of at a 90-degree angle. You could, I guess, technically use a universal joint if you don't need it to be exactly 90 degrees. But a universal joint for a 90-degree angle, you're going to have a very specific kind of universal joint, quite possibly not the ones that we have in our kits, because they don't do 90-degree rotations or change motions. They only do maximum, I think, kind of like that. So that's another option that I've heard people mention, but it's not something that's going to help us building with our VEX parts. There are special, I've said this already, there's special 90-degree, special universal joints with the ability to go 90 degrees. Or you can put like 2 together. Again, you're creating more moving parts for yourself. How do we change rotating motion to reciprocating motion? Usually by use of a cam. The cam, again, is something it's usually not a circular shape centered at the circle. It's usually like oblong, or it's got, it's offset or something's going on, so that there's going to be a follower on the edge, and as it turns, the wider parts will push the follower up higher or pull down. There's also cams where they have something attached on the offset side of it, and it's just rotating it up and down like that at the end. I can show you examples if I can find them. Here's a picture I pulled off the internet with the internal layout showing. I don't know if you can see anything. You can see the sort of bevel assembly at the bottom. I believe they're crown and pinion gears. They are not, like the teeth are not set at angles. I think one of them has teeth that are like poking in, and the other one has like a comb around the outside kind of thing. And so the teeth that poke in will enter in to the gaps like that. And there's a closer up picture. There's some sort of assembly at the top that changes it to vertical. You can kind of see there's an internal gear right there that's beveled. And this guy here is the vertical. It rotates along the horizontal axis. This one rotates around the vertical. And then it pushes it down to the bottom. And there's the mechanism there. Actually, these are at a bevel. These guys are at a bevel. The cogwheels in the video y'all watched with the Dutch guy living in the windmill, that one had some of those sort of cog and crown and pinion things. All right. Group norms. I said this because I set up groups with the folks who are in class. It's proving really difficult. I'm trying to set up groups with my 9th graders, and it's proving really difficult to do so virtually right now. So if you want me to explore this for your class, let me know. Maybe for the next project, I'll have done a run through with the 9th graders, and it'll be something that we can do. for group work. But in the group norms, if I do group work with y'all, it'll be, I'm going to give you guys a set of jobs to do, basically. And this is not saying that only that person can do that job and that is all that person's doing. It's to say that this person's kind of got a domain they're in charge of, so that they know where their responsibility to the group lies, and everyone knows that, like, if this person's not doing their job, they can be like, hey, we need you to do this. This is the stuff you're supposed to be doing. And that way, when I go around and I'm like looking at what people are doing, if somebody is just watching a YouTube video about a video game, I can say, oh, that's obviously not what you're supposed to be doing. What are you supposed to be doing? And they can't say, oh, well, that guy, the smart kid, he's taking charge, or she's the one doing all the writing because her hand, they can't push it off on someone else and say the reason I'm not working is because they're doing something. No, you all have a job to do. That'll be again, if I can figure out how to do it virtually, I'll move that into y'all's class. Yeah. So building a windmill, this was sort of the way it's set up in the PLTW content. This is how it introduces it. It says, using your knowledge of the mechanisms that we've built so far, or seen so far in y'all's case, design and build a solution to situation A, and then later it tells you about situation A. Then you're going to modify your solution to solve a problem described in situation B, and that's coming up. So each of these situations requires a change in the direction of motion by 90 degrees, but requires a different input-output speed relationship. And I don't know why it says basically the same thing again. Each of the structures you need to build need to incorporate the mechanism to change the direction of the output and possibly the input-output relationship, speed relationship. Yeah. And your structure has got to be stable, got to be rigid, it's got to hold the gears in proper relationship to each other. When you all come back to campus, hopefully in the spring, if not, then hopefully later on in the year, I want you guys to be able to actually build some of these things. So we'll probably keep a record of what you said you're going to build, and maybe give you a chance to hands-on build it, get some good build norms together. So first of all, sketch your solution, label your input-output, and then I need to see it. So that's what I want you all to do. Work on the sketching what you might be doing. Try to be specific. Don't just like sketch the outside of a windmill. Make sure you have, okay, I've got something here. This represents a chain and sprocket. This represents a bevel gear right here. Even if you don't think it's a great drawing, make sure you've got them. Label the parts if you need to. And just write down somewhere what the plan is. Or if you want to record a little video, those are always kind of cool. You can upload a little video yourself saying, hey, here's my idea. Explain it to me verbally. That way, if you're not great at writing, but you're better at describing it verbally, you can talk to me about it. So first scenario, you want the output and input to be the same, speed and torque the same. Knowing what you know about mechanisms, how are you going to make that possible? And then in scenario B, you want to have the output speed less than the input speed, so you want it to slow down, and you want the output torque to be greater than input torque, so get stronger. And that's that. That's that presentation. Let me show you here. Let's see what I've got. I thought I had the thing open in Adobe. I guess not. Here's what it's going to look like. I'm going to have the video. I'm going to put this down here. Anything else I can add up, I'm going to add into this so you can see it. These two links will be to basically the PDF version of these things on PLTW. If you have your PLTW login, you want to look at it live over here. It's 2.3 Windmill Construction. And at the very top, there should be a link for distance learning support. So windmill analysis. Let's see. Oh, look at this. Examine the windmills. Get a closer look. So here's a great place to start, just looking at some examples of windmills. If you want an idea about how to design one, I told him to Google Vex windmill and see what other students across the country have done in the past. And there are some that are, fairly straightforward, and there's some that have a lot of things going on. You can look at them to see how they deal with things like stability. Is there a way to make things stable? Let me pause this and go pick up a couple of examples to show y'all, and I'm going to make the video larger so you can see it. Hi. All right, hold on just a second. I'll be right back. All right, hey guys, I'm back. This is one student's windmill. This is just for decoration, really. It doesn't drive it at all, but maybe we can put a crank up there and let it drive it. This student chose to put chain and sprocket assembly in here. So when he turns this one, it's going to turn this gear down here, and he's already attached a bevel system here, which changes the direction. The only problem with the bevel is no matter what, that's going to change the speed of the output from the input speed. And I don't know if this is something they've really talked about in any of the literature. You'll notice we have some work to do. This is not a great angle for this to be at. I think it's at this angle because of the height of this piece right here. You can see it's kind of, let's see if I can get it sort of straight on. There we go. You can see how bent upward this is. That makes it difficult for the chain to nicely wrap around. It also makes it hard for you to turn it. Actually, I don't know if I can turn it right now. Hold up. Oh, that was stuck. That's why. Oh, that's loose. That's why it's so easy to turn that. It's hard to turn this axle. So we're talking about, of course, always improving. We've got a couple days to work on this project. These students are going to come back and take a look at this and see if they can fix how weird this is right here, and make it work better. And we're also going to talk about the speed ratio as part of this project. I had another student. The group did he didn't put it on a base or anything, so it's not up. It's kind of doing this sort of thing. He's got the idea of moving the motion by using just the shaft. He's changing it with a bevel assembly at the top, and maybe I'll put another one at the bottom. This is, I don't know if you can see how, you can probably hear how wobbly this is. We're talking about things with this group like maybe elongating this section of the shaft a little bit so that if we use this as the place where the blades attach, it's not going to run into this. And we've also talked about like maybe we can put a second rail in on the other side of this or something so that we can stabilize it a bit, and maybe how to attach it to a base so we can actually have it stand up. Because if you turn this, I don't know if you can see, if you turn up here, the shaft is moving. You can tell by looking at the gear at the bottom here, this bevel gear. And the interesting thing to do would be maybe to put the same gear, another one of these little bevels at the bottom, because that would make it have an equal speed ratio the whole way down, equal input-output speed ratio and torque ratio. But yeah, this is definitely one of those where if I shake it a lot, it's probably going to work the nuts loose off the bolts. And so that's what we're working on for this group next. I have some groups that are kind of in the middle of it and haven't gotten a lot of stuff put together yet, but that'll give you a couple of ideas to work from. There's always Google. There's always stuff like that to give you some ideas. I don't expect any of you to have the materials at the house, so don't worry about like uploading a picture of one done in Vex. Just sort of sketch it out, best of your abilities. And it doesn't have to be. If you don't know the name for something, let me know. I'll try to go through again and get all the parts out and just do what everything is. I think I've done one before, but I can't remember where I've linked it, so I'll look for that and try to link that up for you in this section to help you out with your descriptions. And let me know if there's anything I can do to help. And I hope you all have a wonderful afternoon, evening, whatever time of day it is you're watching. Y'all take care, and I'll talk to you again soon.